In previous lessons, we studied the characteristics of the linear function graph. Now, we will explore the features of the absolute value function graph. The general form for the absolute value function is as follows: y equals a times absolute value of x minus h plus k. In the case of the linear function graph, we could examine intercepts, domain and range, and slope. The absolute value function has a distinct feature that sets it apart from linear functions. It takes on a shape that opens either upwards or downwards with the vertex as the point of reference. Here, the vertex corresponds to the minimum or maximum value. The coordinates of the vertex are hk in the general form. The graph of the absolute value function always has one y-intercept, but may have 0, 1, or 2 x-intercepts. The absolute value graph has different slopes for different intervals in its domain, and is composed of two distinct half-lines on the left and right of the vertex. The absolute value function is an example of a piecewise function, where the function has different expressions for different intervals of the domain. Generally, functions have ranges based on their domains. While there are simple rules like, for all x, the result is x squared, more complex functions exist. For instance, one could define a function as negative x for x is less than 0, and x for x is greater than or equal to 0. Functions with different expressions for different intervals of the domain are referred to as piecewise functions. Now, let's delve into the graph of the absolute value function. The parent function for the absolute value function mentioned earlier is y equals absolute value of x. To graph this function, let's first create a table. In the case of the parent function, we choose input values of -2, -1, 0, 1, and 2. Consequently, the corresponding output values are 2, 1, 0, 1, and 2. The absolute value function ensures that all values are turned into positives or 0. Now, if we plot these input and output values on the graph and connect them, we obtain the graph of the absolute value function as we observed earlier. The domain input values is the set of all real numbers, and the range, output values, is greater than or equal to 0. As evident from the graph, the vertex is at the origin, and the axis of symmetry is y-axis, specifically x equals 0. Let's draw a slightly more complex graph. Y equals -2 times absolute value of x minus 3 plus 4. Step 1, we'll plot the parent function. Step 2, if we multiply the function's output values by -1, it reflects across the x-axis. Step 3, multiplying the output values by 2 results in a vertical stretch by a factor of 2. Step 4, we perform a horizontal translation 3 units to the right. Note that this is a rightward shift despite the presence of x minus 3. Step 5. A upward translation by 4 units completes the graph. Let's observe the transformation process sequentially. Overlaying the graphs may appear a bit complex. As seen in the graph, you can identify the coordinates of the x-intercept, y-intercept, and the vertex. Since the graph points downward with the vertex as the reference, the range is less than or equal to 4. See you next time!